Hello students, myself Dr. Jyoti Shegokar. I welcome you all in my YouTube channel Chemistry in Engineering, which is made for the study of engineering chemistry as well as different students of BSc also can refer different points which are there. So our today's topic of discussion is calorific value. Guys, before that, if you have not subscribed this channel, not like the videos, please view the channel, watch all the videos and subscribe it, like it and share it your friends who generally those who are away from you or who want such type of knowledge. So without wasting a time, here we will start our topic, calorific value. Guys, actually calorific value, this topic is related to our topic from the syllabus. Its name is energy science. Energy science particularly which is related to the fuels. Now fuels and combustion, this is one of the topic, and the fuels are those substances which gives us energy, which is in the form of heat, and that's why they are used worldwide, as this is the era of energy, of a power. So that power is from the fuels. So fuels are the substances which are able to give us energy. On combustion, they gives us energy which is in the presence of oxygen only. So that fuels are having one property which is one of the most important property. It is because on the basis of this property there are number of factors, or the quality of that fuel can be evaluated. So that is called as a calorific value. Now this property is a very important. With that, and another properties are also there, like ignition temperature. We have to compare that fuel. We have to compare the different types of fuels or samples of coals from the different type of mines. Means whether it is a sample of same, that is a coal, but if it is from the different type of mines, it will be different. It is having the different properties, somewhat different percentages of its components. So for the study of that, for the getting the proper quality of fuel, for getting proper price of fuel, for the required utilization of the fuel, there is a need of studying calorific value. Now coming towards our point, calorific value. That word calorific itself indicates that there is a presence of some calories, and we have idea generally that what is calories. Calories is nothing but energy. So those energy which is from the fuel, it's called as a calorific value. But systematically and specifically, if we want to define it, it is nothing but an energy, quantity of energy or an amount of energy, because it is for the particular volume of the fuel. Particular quantity of the fuel is there. So it is a quantity of heat or energy which is released when 1 unit weight or 1 unit volume or 1 unit mass of substance is completely burnt. That is called as a calorific value. In another word, we can say that the energy which is from the 1 unit of fuel, it's called as a calorific value. It is measured in calories, and that fuel as considered as a substance, so it must be as a heat. So this energy, this calorific value, it is an energy which is released when a unit weight of substance has been completely burnt. Now that fuel, it may be in any type of state. On the basis of its state of matter, there are different types of fuels: solid fuels, liquid fuels and gaseous fuels. Solid fuels, which includes different type of fuels like wood, coal, coke, peat, charcoal, bituminous coal, lignite, anthracitic coal, all the type of solid fuels which are there for giving energy, that are called as the solid fuels. So when we consider solid fuel, we have to consider 1 unit weight. That is, it may be 1 gram, it may be 1 kg, it may be 1 milligram. So that is 1 unit weight. So that 1 milligram of fuel we have to burn. We have to carry out its burning, and during that burning, those energy will be produced. That is called as a calorific value of that total amount of the fuel. Are you getting? So this is called as a calorific value. Now If it is in case of liquid, for example, there is a petrol, gasoline, or there is a kerosene. So at that time we will have to consider 1 ml, 1 dm cube of the fuel, of the liquid, that is to be considered. If it is in gases, we have to consider its 1 unit volume of the substance. So that is to be burnt, and after burning that, it is to be burned not in the open space, but it is to be, that burning process is to be carried out particularly, specifically in the calorimeter, which will give us the exact value of the product, that is the quantity of heat. So in this way, quantity of heat which is released or which is from the fuel, that is evolved from the fuel, when 1 unit weight or mass or volume of substance has been completely burnt, that is called as a calorific value. Guys, on the basis of this calorific value, it depends that what is the quality of coal. Means if a single unit of the unit weight of that substance gives more energy, so all the substance will ultimately give more energy. So if there is a higher calorific value, there will be the good quality of the coal. So on this basis, we can examine that coal, we can establish the price of the coal, quality of the coal, or its naming according to the commercial classification. So on that basis, there is a study of calorific value. Now guys, there are 2 types of calorific values. On the basis of that, how that process of burning we carry out, on that basis there are 2 types of calorific values. Number 1, gross calorific value. I wrote here in very short so as to minimize our time. So gross calorific value, CV is for calorific value. Gross means higher. So higher calorific value, and we have to consider the same type of sample. So how can be the higher calorific value is there? Now it means that the calorific value, that is the amount of heat or energy which is released when 1 unit weight or mass or volume of substance has been completely burnt, and the products are allowed to cool at a room temperature. Products are allowed to cool at a room temperature. It means that we have to cool down the reaction after the getting energy. What will happen by that? By the burning process, if in the fuel there is a presence of H2O, in the fuel there is a presence of hydrogen as a H2, and this H2, when it burns in presence of oxygen at about particular temperature, it will convert into H2O when it is treated with a half mole of O2. So there is a formation of H2O, and this H2O at the temperature of the fuel, at the temperature of the burning reaction, it is a very high temperature. So at that high temperature, this H2O is in the gaseous state. But if the reaction is cooled down up to room temperature, that gaseous state water vapor is converted into liquid water vapor due to room temperature. H2O in liquid, and that during conversion of vapor water into the liquid water, there is evolution of energy. There is a production of energy which is called as a latent heat of condensation. Latent heat of condensation, and which is 587 calories. If it is particularly for 1 mole of hydrogen, it is 587 calories. So that amount of energy which is released during the process of condensation must be added in the calorific value. Is it? So those calorific value which was there during the higher temperature, it is now changed because there is an addition of this particular amount of energy. It is not less, guys. So 587 calories of amount of heat has been added, which is called as a latent heat of condensation of the water. During the conversion of water vapor into the liquid water, there is a removal of this energy. So in this way, we can get the gross calorific value. Now, what should be the net calorific value? Net is a less calorific value or lower calorific value. Now, it is what? Then it is again same calorific value, but the products which are produced at a temperature of the boiling temperature of the the burning temperature of the fuel, at that temperature the products are allowed to escape into the atmosphere. Means here that we wrote at the room temperature, instead of that here products are allowed to escape. It means that allowed to escape. It means that at that temperature reaction has been just opened. We have carried out the burning of one unit of the sample of the fuel, then there is a production of an energy, and after that at that higher temperature reaction is opened. That means the all products, it includes this H2O in gas also. So this product is allowed to escape into the atmosphere, means that water vapor is removed. There is no any latent heat of condensation of water. So that's why the gross calorific value is a higher calorific value because of addition of this latent heat of condensation, and the net calorific value is a lower calorific value because of absence of this latent heat of condensation. So in this way these are different type of calorific values. Calorific values are measured in kilocalories per kilogram or calories per gram. Okay, now we will move towards the percentage calorific value. If we will see 1 mole of carbon, when it is burnt, there is a formation of 96.6 kilocalories, not in calories, 96.7 nearly kilocalories of energy is produced. And when 1 mole of hydrogen is burned, it is 69 kilocalories or 69 kilocalories of heat is produced. Now if we see that 1 mole of carbon will give such amount of an energy, while 1 mole of hydrogen will give such amount of an energy, and 1 mole is nothing but the amount of up to the gram of this molecular weight. As carbon is having its molecular weight 12, carbon is having its 12 molecular weight, so for 12 gram of carbon such amount of energy will be produced. So what about for 1 gram? So from that, if we calculate 96.7 upon 12, which is a gram of carbon, that is 1 mole of carbon, we will get its amount, that is 8137. So such amount of calories of heat is produced when 1 gram of carbon has been burned. In the same way, if we see for hydrogen, when 1 mole of hydrogen has been burnt, there is a formation of such a 69 kilocalories of energy is produced there. So it is, if it is calculated for 1 gram of carbon, we know that 1 gram of hydrogen, we know that 1 mole of hydrogen, it is H2. So there are 2 atoms of carbon, and it means that as it is having its molecular weight 2, we will divide it by 2 to get 1 gram of hydrogen. So by dividing it by 2, we will get this particular amount, 34500. So by getting these both amounts from the burning process of carbon and hydrogen, you will see that why we are only burning this carbon and hydrogen, because these are the components of fuel which are there to give energy, to produce energy in the fuel. In any type of fuel, if you will see that only the carbon and hydrogen are those components which are responsible for giving energy. So we must have to consider only carbon and hydrogen. So we have considered its energy. So on that basis, we can calculate percent calorific value, which is equal to percentage of carbon, which will be given into 8137. It is just from the calorific value of this. Here there is a one line for dividing, plus percentage of hydrogen, it is there, into 34500 divided by 100. It will give us percent calorific value. Okay, now moving towards the gross calorific value and net calorific values relation. So as we know that this reaction is there, H2 plus half of O2 will give you one H2O molecule. So during that, if you will study 2 gram of hydrogen, then here as oxygen is having its molecular weight 32 O2, therefore for O it is 16, and here there is a formation of 18 molecular weight which is there of H2O. So if for 2 grams of carbon, so this amount of 18 is there. So what about for 1 gram of hydrogen? Sorry, for hydrogen. So therefore from this 2, here 1 gram of hydrogen is forming here 9 gram of H2O. Is it? For 1 gram of hydrogen, formation of 9 gram of H2O, and during the burning of 1 mole of the hydrogen, there is a formation of such amount of latent heat. Is it? So from that particular reaction, we can say here that gross calorific value is equals to net calorific value plus latent heat of condensation. It is a simple equation. But latent heat of condensation, when we have to consider, it is just like this: net calorific value plus hydrogen. This hydrogen is a mass of hydrogen particularly. And here in this case, as we will write here 0.09 plus 587. 587 is a calories of heat, and this, what about the 0.09? It is nothing but this 9. That is a gram of water molecules produced. We means when we have to consider this hydrogen as a mass of hydrogen, then it will be just 9. Means net calorific value plus mass of hydrogen plus 9 plus 587. But if this hydrogen is in the form of percentage of hydrogen, at that time we have to percentage of hydrogen means hydrogen upon 100. So as upon 100 is there, we have just shifted this pointer towards the left side, that is 0.09. So here hydrogen is percentage of hydrogen. If the problem is given in percentage of hydrogen, then simply put value here and write this particular equation. And if the value is given in mass of hydrogen, at that time simply we will write here mass of hydrogen plus 9 into 587. So in this way, this is the relation between gross and net calorific value, and in this way there is a study of calorific value. Guys, you might have understood all these topics. I am sure totally that you must understood these different type of topics, as you will see it seriously or properly. So this is a very important topic in terms of our syllabus as well as for our general study. So calorific value, it is studied generally from the 8th standard. We have to study calorific value, but somewhat if we have to elaborate, this video is very, very important for you. So guys, thank you for watching this video. Thank you once again. So if you like it, actually like, share and subscribe, and also hit the bell button so that you can get such type of videos as soon as they are uploaded. Thank you very much.